Let's have an example. Draw the Lewis structure of copper 1 oxide, which has a formula of C2O. This compound is an ionic compound, which tells us that there will be transferring of electrons here. The type of bond is basically ionic. Let us start with establishing the individual Lewis dot symbol of the elements involved in the compound. We have copper and oxygen. We need 2 copper atoms as per the formula and 1 oxygen atom. Copper has 1 dot, which tells us that in this compound, copper has 1 valence electron. Transition metals have varying valence electrons. That is why it's difficult to apply the general trend. We can deduce the number of valence electron or electrons copper has or will have based on first the name of the compound. This portion of the name tells us that the copper in this compound is Cu plus ion. It has a positive 1 charge, or based on the crisscross method. If you're familiar with that, crisscross method is applicable for ionic compounds. Cu, we know that oxygen has a negative 2 charge. We don't know, let's say we don't know the charge of copper. In crisscross method, the absolute value of the charges will become the subscript of the atoms in the formula. In this case, copper will become, or in this case, copper will have a subscript of 2 because the absolute value of negative 2 is 2. Oxygen will have a subscript of X. In our formula, oxygen has a subscript of 1. Therefore, X is equal to 1. Hence, the charge of copper is plus 1. Let's proceed. As you can see here, there are square brackets. These brackets are necessary for us to appropriately label the charges of each atom. Square brackets are only used when establishing the Lewis structure of an ionic compound. Here, the mechanism is electron transfer. Copper is a metal, so it is most likely to donate the electron. It will donate 1 electron to oxygen. The copper atom will now become a copper ion. It will have a plus 1 charge, while oxygen will have a negative 1 charge. The other copper atom will also do the same. It will donate 1 electron. It will become a copper plus 1 ion. The oxygen will now have a negative 2 charge. So you can see the charges are balanced. Negative 2 plus 1 is 0. So the Lewis structure of copper 1 oxide looks like this. Next is chromic oxide, Cr2O3. First is to establish the Lewis dot symbols. We have 3 oxygen and 2 chromium atoms. Chromium atoms can donate 3 electrons. Oxygen atoms need 2 electrons each. So these 6 electrons will be distributed to these 3 oxygen atoms. 2 of the 3 electrons from this chromium will be transferred here. 1 will be transferred here. 2 of the 3 electrons that this chromium can donate will be transferred here. The remaining 1 will be transferred here. So you can see again, the charges are balanced. 3 plus 3 minus 2 minus 2 minus 2 is equal to 0. And this is the Lewis structure for chromic oxide. Let's have an example, which is a covalent compound, chlorine trifluoride, ClF3. These are the Lewis dot symbols. We have 3 fluorine atoms and a chlorine atom. The central atom is chlorine. This is based on the techniques that we have discussed. The number of dots, we are using the second technique. The total number of valence electrons present in the structure will be 28, 7 from chlorine, and 7 from each of the fluorine atoms. The number of dots again is the remainder of the total number of valence electrons divided by the multiple of 8 that is very close to the total valence electrons, and that is 24. So 28 divided by 24, we will have a remainder of 4. Therefore, in this structure, chlorine will have 4 dots. Next is the number of bonds chlorine will make. The number of bonds is the number of valence electrons minus the number of dots. So the number of bonds chlorine will make in this structure is 3. So let us rearrange these symbols. The central atom will be chlorine. Chlorine will establish 3 bonds like this and 4 dots. 1, 2, 3, 4. So we will just rearrange this structure and we are all good. Let's check 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 10. We have discussed that there are exceptions. This exception falls under expanded octet because the central atom, which is chlorine, has more than 8 valence electron, and it is alright and it is possible. Enough of the examples. Let's proceed to formal charge. Formal charge is the difference between the valence electron or electrons of an atom in uncombined state V sub u and the valence electrons associated to that atom in the Lewis structure V sub L. So the formal charge is equivalent to V sub u minus V sub L. V sub L is the sum of the number of dots and half the number of electrons in a bond. The net charge of the compound depends on the sum of the formal charges of individual atoms participating in the bond. So let's pay close attention to the charges here of NH4. We have a +1 charge in nitrogen, and we have 0 or a neutral charge in all of the hydrogen. Why is that? We have established that the formal charge is equivalent to the number of valence electrons of the atom minus the number of electrons associated to it in the structure. So the number of valence electrons associated to nitrogen in the structure is 4, again because we only consider half of the number of valence electrons in the bonds. Each of these single bonds have 2 electrons, half of that is 1. So if we have 2, 4, 6, 8 valence electrons from the bonds divided by 2, and we have 4. So 5 minus 4 is +1. That is why nitrogen has +1 charge. Now hydrogen has 0 charge because we know that hydrogen, its valence electron is 1. The number of valence electron associated to it in the bond is also 1. That is why its charge is 0. Now we have mentioned that the net charge of the compound depends on the sum of the formal charges. So the formal charge of NH4 is +1. Finally, we are down to our last discussion. Let's finish it with resonance. Resonance structure is one or more Lewis structure that can be used to depict a single molecule. A double-headed arrow is used to denote resonance. So basically, resonance tells us that there could be more than one possible structure that can represent a compound. These are resonance structures of carbon dioxide. The resonance structure with the lowest sum of the absolute value of the formal charge of the individual atoms will be the most preferred structure because it's more stable. It doesn't mean there are more than one possible structure to characterize or to describe a compound. All of them exist or all of them are valid. We need to verify which one is most preferred, which one is more stable. The sum of the absolute values of these charges is 0. So the absolute value of 0 is still 0. 0 plus 0 plus 0 is 0. Now in this structure, the absolute value of 1 is 1. The absolute value of -1 is +1. The absolute value of 0 is 0. So 1 plus 1 is 2. Now again, the most preferred structure, the most stable structure has the lowest sum. This has 0, this has 2. So therefore, this is the most preferred structure and this is the more stable. And that ends our lecture. These are the references. I hope you learned something from these discussions. Thank you for listening.